Hey folks, how's it going? This is Rob coming to you with a recap of homework quiz number 6 for Math 134, Spring 2020. Okay, so in this video, I'm going to explain to you these problems, and these were based on our integration. We're now moving into definite integration and the idea of area under the curve. So this question says, find the area under the graph of the function f on the interval AB. So essentially what it's asking you to do is it's asking you to integrate from -1 to 2 the function x squared plus 4 with respect to x. Okay, and so kind of like as we talked about today in class, that integral is -1/3 x cubed, or x cubed over 3. And again, if you think about it, if I was to take the derivative of this, the 3 would come down with the power rule. You'd get 3/3, right? So it would look like if I was to do this out, and then the power would go down to 2. Well, 3/3, that cancels, so that becomes -1, or just negative x squared. So you can see that's what you get inside the integral. And then the antiderivative of 4 is 4x, because if you take the derivative of 4x with respect to x, it would just be 4. Okay, and you can do a similar thing with the power rule there. So you could think of this as 4x to the power of 1. So the 1 would come down, and you'd get 4x to the 0, and x to the 0 is just 1, so you get 4. So you can see how, again, that when you differentiate it, gives you the 4. And then we want to integrate this. We want to integrate this here from -1 to 2. Okay, so what that means is, by the fundamental theorem of calculus, first we're going to plug in 2. Okay, then we're going to plug in 1. I'm going to put this in parentheses because I need to do the difference. So we're going to do times -1. Sorry, if I said 1, I meant -1. Okay, because the fundamental theorem of calculus says you plug in the top number, you plug in the bottom number, and then you take those respective outputs that you get and you take the difference of them. So here I get 2 cubed is 8, so that becomes -8/3. 4 times, I don't know why I put a 3 there, it should be a 2. 4 times 2 is 8. I think I was looking at my exponent. Okay, and then in the parentheses, okay, well, -1 cubed is -1 times a third, -1/3, right? A negative times a negative is a positive, -4. All right, and then I can convert these to thirds, so it's -8/3 plus 24/3. Okay, and now this would be -1/3, and then minus -4 is plus 12/3. Okay, so -8 plus 24, that's 16. Minus 1 is 15. Plus 12 is 27/3, which is equal to 9. Okay, so please make sure you understood what I did there. That's just a simple, or hopefully rather simple, case of integration and phrasing integration in terms of finding the area under the curve, or under the graph. All right, so and if needed, rewind, but then in a second I'm going to move on to the next problem. So for the next one, here's what I saw. I really like this. A lot of people did it like this. They did the 0 to 4, and they realized, wait a minute, I could just distribute here. And since these are the same expression, you get the exact same answer, right? So there's nothing that says that you can't rewrite the expression inside of here to get an equivalent one. There's nothing that says you can't do that. The one thing that I saw that does not work is there's no product rule, right? You can't just do the integral of x times the integral of x squared minus 1. We don't actually have a technique to do that. It is covered if you continue in the book, I believe, beyond what we do. And then it's also covered in Calculus 2. It's a strategy called integration by parts. But we don't talk about that in this class. And in fact, if you think about the distribution, you don't even need to. Okay, the other way you could do it is this. You could say, let u equal x squared minus 1, so that du is 2x dx, so that du over 2 is x dx, and then make the substitution 0, 4 of, put the 1/2 outside, u du. Okay, and then you could go from there. You could integrate it there, right? Just using the u substitution. Okay, or you could even do it another way. Method 3, you could do the same u substitution, but then you could plug in 4. 4 squared is 16, minus 1 is 15. 0 squared is 0, minus 1 is -1. And then you could finish it off with u. So let's see what happens if you do each one. So this will be the blue option. So here I integrate. I get x to the 4th over 4, or 1/4 x to the 4th, minus x squared over 2. Okay, so I evaluate that. That is, so it's 4 to the 4th over 4. Now you would have a scientific calculator for this, as you might have seen in the directions, because 4 to the 4th is not something you can do in your head. So 4 to the 4th is 256, divided by 4 is 64. 4 squared is 16, divided by 2 is 8. When you plug in 0, both numerators are 0, so you're just subtracting 0, and you end with 56. 64 minus 8. Okay, and remember, those were just from plugging in the 8. Okay, so maybe on my calculator I do that, I get 56. Okay, that's strategy 1. Strategy 2. Maybe I can help. Ooh, I can even move this over. Yeah, nice. Okay. Strategy 2 is a strategy where I use u substitution. So if I'm going to integrate u du, it would be 1/2 u squared, right, or u squared over 2, depending on how you want to do it, from 0 to 4. Okay, and then you take 1/2 of it. So when but you're not done, because in this case you actually do have to do, because I didn't change the limits, you do have to go ahead and plug back in your original u. Okay, and then so then what you want to do though is, don't forget, we want the squared there. That's what was going on. Okay, so we got 4 squared is 16, plus 1 is 17. So this is what it looks like. 1/2 of 1/2. Okay, and remember, this is the part that we're integrating. Okay, so 1/2 of what we said, 17. Oh, sorry, this is -1. So 16, 15 squared. So that would be okay, minus, so then I got to plug in 0. So 0 squared. So you get, see, there's the 15 though, and here's the -1. So this would be -1 squared would be 1, times 1/2 is 1/2. Okay, so 1/2 of 225 is 112.5, minus 0.5 is 112, and 112 divided by 2 is 56. So I'll show you what this looks like again. So if you do this, 1/2 of 225, so looking at 1/2 of 112.5 minus essentially 0.5. So it's 1/2 of 112, or 56. So you get the same answer there as well. So as you can see though, from my perspective, just a little bit more difficult to work through it. Maybe that's why, think about that substitution. Here, I'm just going to go like this, 1/2 u squared, and that's being multiplied by 1/2. But now, since I made the substitution, these are u's. So I can just go ahead and I can just do the plugging in. So it's 1/2 of 1/2 of 15 squared, which is 225, minus 1/2 of 1 squared, so that's minus 1/2 of 1. And you can see that essentially these are the exact same step, right? These two things are literally equivalent to each other. So therefore, we can say, well, look, it's going to just be the same thing, right? So it's going to be 1/2 of 225, which is 112.5, minus 1/2 times 1, right? We know what that is. So it's 1/2 of 112, or 56. So this was definitely I know I spent a good amount of time doing this. I just wanted to show you that there's multiple ways that you can do these problems. And just because you don't do the problem the same way as your classmate doesn't mean you're wrong. As you see, we took 3 strategies here: distributing and simplifying with and then integrating the equivalent expression. That's got to work, right? Because if 2 expressions are equivalent, they have to have the exact same integral and derivative for that matter. Okay? Now, similarly, we could have done the u substitution, looking at the x squared minus 1 as a kind of thing that's difficult to work with. And there's arguments to be made there. And then we could choose to say, hey, I like to do the step where I plug the x back in at the end. So that's what I'm going to do. And we leave the limits of integration the same. Or you take the limits and you redefine them. And you do the rest of the integral in terms of u. Okay? So you don't need to necessarily understand maybe all of them. And you don't need to necessarily be able to master all of them. If you can, then I think it will make your life a lot easier. Okay? But when you're ready, what you should do is go ahead and, rewind if needed. And then when you're ready, unpause. And we will go ahead and move to the next problem here. Okay, so here we are. We are now on problem number 3. This is the application problem. Okay, so a bottle of white wine at room temperature is placed in the refrigerator at 3 p.m. Its temperature T hours after T hours changing at a rate of. So essentially, suppose f of t is the temperature at time t. Okay, this is the derivative, essentially, the change, okay, in Fahrenheit per hour. So how many degrees will it drop by 8 p.m.? What will the temperature of the wine be at 8 p.m.? So this is the derivative. What I'm going to do is I'm going to integrate it, because that gets me back to the original temperature function. And what this is going to do is it's essentially going to give me the accumulation of, how much it has dropped, right? The total amount of change. Okay? So essentially, what I want to know is how much temperature change has actually occurred. So I'm going to integrate it from 0, which represents 3 p.m., to 5, which represents 8 p.m. So I'm going to start by factoring out the constant, negative 18. And what we learned here is you want to do u substitution. Okay, and with e, you always want to define the exponent to be your u value. Don't put e in there, because when you do that, you're not going to be able to replace everything in there. So, for example, let me just put this back to purple. This should have a dt, and this should have a dt. So essentially, du is equal to negative 1.2 dt. So you have the dt in common, and so what I'm going to do is I'm going to say, well, if I divide both sides by negative 1.2, then I get dt, and I have something I can replace it with. So watch what happens when I do that. This is how we know we've got the right substitution. So my negative 18 is still there. I'll draw my integral for now, and then I have e to the now that's I don't need to put the negative because the negative's covered there. E to the u, because u is the same thing as negative 1.2t. Then I get du over negative 1.2. That's the same thing as dt, right? We've defined it that way. So now I'm going to remove this because this is also a constant. Okay, and I get negative 18 over negative 1.2 times the integral of, now we need to define this. So this was originally 5, 0, but because we switched to u, we now need to plug in 5, giving us -6, and plug in 0, giving us 0. Okay, think about that, because if you were to plug in 5, you get -6 there. So now what I'm going to do is I'm going to e to the u du. Okay, and now e to the u, well, the derivative of e to the u is e to the u. So I want e to the u, so I've got -18 over -1.2 times e to the u from 0 to -6. So it's -18 over -1.2 times e to the -6 minus 1. And now we've got to figure that out. So on my calculator, what I'm going to do is I'm going to do e, find my e button, to the -6 minus 1. And that's about -1. And then I'm going to multiply by -18 over -1.2. And what I get is, this is equal to about 14.96 degrees. So what that means is the temperature has dropped, okay, by 14.96 degrees. So it started at 72. It dropped 14.96 degrees. Okay, and so what I get is I get 57.04 degrees Fahrenheit. So it's 57.04 degrees, and it's dropped by 14.96 degrees. Now, this was changed from the original one that appeared. I changed the exponent. So originally the exponent was 0.6, but because I made the exponent, it looks bigger, but because it's a negative, it's actually smaller. So you actually should get a smaller change than what you would have gotten otherwise. Okay, so hopefully you found this video to be helpful. I encourage you to, make use of this in helping you really solidify some of these important ideas. Feel free to send me questions anytime if you have them, and stay for office hours if needed, because we want to close off the semester strong. But keep it up, and remember, you can do it. All right, see you next time. Have a wonderful day.